Hi, welcome to the session. In today's chapter, we'll be learning about motions of the earth or movements of the earth. What are the movements earth has? We know earth moves on its axis. This we have learned in the previous class. It moves around the sun as well. It's a very small chapter but important. We have some new terms in this chapter. We'll learn them. Earth's movement on its axis is known as rotation. It rotates on its axis. So now the earth moves around the sun as well. It moves around in a fixed path known as orbit. This movement is known as revolution. The plane formed by the orbit is known as the orbital plane. That means the plane formed by the orbit and the center of the earth. The axis of earth makes an angle of 66.5 degrees with this orbital plane. This angle is 66.5 degrees. We know earth has a spherical shape or geoid shape. Due to this shape, only the half portion of it gets sunlight. So the portion facing the sun has day and the other half has night. Now the circle dividing this half with day and the half with night is known as circle of illumination. The earth takes 24 hours to complete one rotation on its axis. The period of this rotation is known as Earth Day. This rotation is a daily motion. To be said, it was the ancient Indian astronomer Aryabhatta who stated that the earth is round and rotates on its own axis. We can be proud. The revolution or the motion around the sun takes 365 and 1/4 days or 1 year. But we just ignore that 1/4 of the day and round up and say 365 days. 1/4 of the day or the 6 hours saved every year are added to make 1 day or 24 hours over a span of 4 years. This extra day is added in the month of February. So every 4th year, February has 29 days instead of 28. Such a year with 366 days is known as leap year. A year is divided into seasons: summer, winter, spring and autumn. Why are there so many seasons? It's because of the Earth's position around the sun. The Earth moves around the sun in an elliptical orbit. Elliptical means egg-shaped or oval-shaped. Throughout its orbit, the Earth maintains its inclination or bend. So, the change in the position of the Earth around the sun during its revolution and the inclination of Earth's axis in a fixed direction cause seasons. Have a look at this figure, the Earth's revolution around the sun. On 21st June, the northern hemisphere is tilted towards the sun. If you are not familiar with the term hemisphere and don't understand the concept, please refer to the description box. I'll give the link to the previous class. Take time to watch it so you will know the base terms. Okay, coming back to this figure. On 21st June, the northern hemisphere is tilted towards the sun. The sun rays fall directly on the Tropic of Cancer. Hence, this area gets more heat, but the areas near the poles receive less heat as the sun rays are slanting. The North Pole inclined towards the sun and the area beyond the Arctic Circle experience continuous daylight for about 6 months. That means you have only day, not night in this region for about 6 months. You can see a large portion of northern hemisphere experiences continuous daylight. This half has summer. The longest day and the shortest night at these places occur on 21st June. At this time in the southern hemisphere, it's reversed. It's winter there. The nights are longer than days. This position of Earth or this day is known as summer solstice or midsummer. On 22nd December, the Tropic of Capricorn, here the Tropic of Capricorn receives direct rays of the sun as the South Pole is now tilted towards the sun. A larger portion of southern hemisphere gets light. It's summer there with longer days and shorter nights. In northern hemisphere, the reverse happen. It's winter there with shorter days and longer nights. So, this position of Earth or this day is known as winter solstice. For this reason, on 25th December, Christmas is celebrated in Australia in summer. We have seen the effect of sun rays on Tropic of Cancer and Tropic of Capricorn. Now coming to the equator, on 21st March and 23rd September, direct rays of sun falls on the equator. At this position, neither of the poles are tilted towards the sun. So the whole earth has equal days and equal nights. This is called equinox. On 21st March, it's spring in northern hemisphere and autumn in southern hemisphere. On 23rd September, in northern hemisphere it's autumn and in southern hemisphere it's spring. So we have seen that there are days and nights due to the rotation of Earth, and there are changes in the seasons due to the revolution of the Earth around the Sun. In this chapter, we also learned terms like winter solstice, summer solstice and equinox. Thank you.